that readable? Everybody see that okay? Awesome. Okay. Well, so like I said, I want to make sure that everybody starts off with a good footing in the Java language. Maybe for some of you, you haven't seen this stuff in a while, or others, it might be pretty new, or you just want to review. So tonight, I will do some lecturing. We'll walk through these slides. And here again, I'd like to think that, well, so if you were watching this on YouTube, you would have fast forward and pause and rewind available to you. I want you to feel that you have the same thing available here. So if there's something that I'm saying is like, oh my God, this is old hat, I've known this stuff for years, let me know and I can go faster. Or, more likely, if it's something new to you or there's like something you've seen before and you want some more detail on it, raise your hand and do a rewind. If you need to like digest something, tell me to pause. So, as much as I love to hear myself talk, I'm here to have you guys learn. And so, I want to make sure that you're getting what you need out of this. So, again, you've got a remote control, so let me know. Okay, Java. So Java is more than just a language. I think of it as a programming platform. And a programming platform that, yes, has the Java programming language, a set of standard libraries for you to use, and the runtime environment, the Java virtual machine in which Java programs run. The syntax of Java is purposefully meant to resemble C. When you think about when Java came out back in the mid-90s, C was the dominant language, and so people were used to that, and there was lots of textbooks around that. And so it looks a lot like C, but it's object-oriented, like C++ and Smalltalk and other languages, and has some features that that C doesn't have, such as a built-in Boolean type, support for international character sets, native string type, and automatic memory management, garbage collection. So what I want to talk with you guys about is the Java programming language, sort of the environment that you work in. So we'll answer the question, what is Java? We'll go through an overview of the language, touch on what I think are some of the high points, the important things to know and remember about the language. Then we'll go into some details about object-oriented programming, which you might have seen, which I'd assume that you've seen before, but maybe not seen it in the Java way. And then we'll finish off with a discussion of tools for compiling and running Java. Okay, so what is Java? Well, the original Java white paper, which is probably put together by some marketing guy, says that Java was a simple, object-oriented, distributed, interpreted, robust, secure, architecture-neutral, portable, high-performance, multi-threaded, and dynamic language. What the hell does all that mean? I like to think about Java the way James Gosling did, which is C++ without the guns, knives, or clubs. And actually, a quick disclaimer here. So the C++ 11 standard is coming out, and they've really made C++ much nicer than it used to be. Back in, oh gosh, almost 20 years ago, 20 years ago now, when they were putting together Java language, C++ was really hard to use, and the implementations were very different. And so Java was kind of a backlash to C and C++. It's been a long time, and all the languages have matured and have progressed. But I think you'll find the Java language still has a lot to offer. So there's the Java language, but there's also this Java platform that allows you to develop a code which is portable and hardware independent. Additionally, Java provides a bunch of standard APIs, application programming interfaces. It's basically a bunch of Java code that does stuff that you need that you don't have to write. So things like common data structures like linked lists and hash tables, standard libraries for doing file I/O, networking, all this really good stuff that just comes with Java. Now, Java grew up at the same time that the internet grew up, and so as such, built into the environment, built into the platform, is support for networking, graphics, security, sort of the functionality that you need in the internet age. And well, I say Java is rapidly becoming. I would say that Java has become, and actually even hit the peak of the language of choice for application and enterprise level computing. So if you want to learn more about working with Java and the tools available with it, you can go to that URL to download some of the environment. I also have a screencast that talks about the tools that you'll need to work with Java. If you read much about Java, and certainly I'll be using some of these acronyms in your in this class, there's some alphabet soup that you need to be familiar with. So there's something called the JDK, which is the Java Development Kit, and this is the language tool set that Sun originally put together. So this is like the compiler and the runtime environment, the Java virtual machine, all the standard libraries. That's the that's the JDK, the Java Development Kit. Somewhere along the lines, the geniuses of marketing decided that the platform was mature, and now it's Java 2. And so there's Java 2 J2 SE, which is Java 2 Standard Edition, which is well, basically the Java runtime environment, the VM and the libraries and stuff like that. As I touched on before, there's something called Enterprise Java, which is all about providing APIs and tools for building enterprise level applications. So you've got stuff on working with databases, modeling things in the middle tier, your Java beans, your enterprise Java beans, your business logic, and a web front end. So there's a whole suite of tools and technologies that are called J2EE, Java 2 Enterprise Edition. A couple years later, Java 5 came out. So there was not really a Java 3 and a 4. It's like now we're Java 5. Which showed the maturity of the platform and also introduced a bunch of new language features that we'll highlight throughout. And Java 5 was, oh goodness, early 2000s, I think. And finally, they got rid of all this number stuff, and now it's just like Java Platform Standard Edition. So the reason I point all this stuff out to you is that I'll be using some of these acronyms, but also as you're doing research, on your own, looking on the web, other people out there will use this stuff also. Okay, I want to take a few minutes to talk about the programming language itself. It was developed in 1995 at Sun Microsystems by Ken Arnold and James Gosling. And the whole idea is that a Java program is built from classes. So there's sort of the unit of data is a class. Classes have methods that consist of statements that perform work. Now in Java, every class is in something called a package. It's a naming context for your classes. And program execution begins at a method whose name is called main. It has one argument, which is an array of strings, that are the command line arguments that are passed in from the command line. So just like you have a main function in a C program, you have a main method in Java, and that's where program execution starts. So, hello world in Java. The first thing you need to do is declare a package for your class. This is like what naming context it's in. Packages often look like URLs or domain names in reverse, and so it's package edu pdx cs410j.lang. So all the classes in the lang package all have to do with the Java language. You declare a class. You can say it's public. We'll get into public in a little bit. The name of the class is hello, and it's got this main method, which is public, static, and void, and takes an array of strings called args. And it presents a standard out by saying system.out.println hello world. So this is hello world in Java. And oddly enough, there's quite a lot here, right? We'll be talking about what public and static mean and what system.out.println really means. But this is how you do hello world. So as I said, the Java programming platform and the language was designed to be platform independent. This write once, run anywhere dream. And the way this is accomplished is by compiling Java source code, Java classes, into a binary format called class files that contain instructions not for the underlying processor, but for a virtual machine, a Java virtual machine. The JVM itself, of course, is a highly optimized piece of software written in a platform-dependent language, something probably like C, because execution execution speed is really important. So they're willing to sacrifice language expressibility for absolute performance. Is the concept of the JVM and bytecode familiar to you guys? So okay. So how do you compile a Java source code into bytecode? Well, first of all, you need to put the source code in a file that whose name corresponds to the name of the class. So, for instance, that hello world program. Oh, and by the way, the name of the file is the name of the class, and the name in the class, sorry, in the source file is in a directory hierarchy that parallels the package name. So here we had in a package edu pdx cs410j lang hello. That lives in a source file edu pdx cs410j lang hello.java. So at first blush, this might seem a little annoying. It's like, oh, wow, I have all these directories, just for this file. But it really helps keep your code organized. These conventions have served the Java community very well over the years, and it's just how people do things now. So you've got your source code that lives in a file that ends with .java, is a text file, and that source code is compiled into one of these class files using a tool called javac for the Java compiler. So the way you invoke javac is that you put it on the command line javac, and you need to tell it where to put the class files. And so you can say -d for destination, ~classes. It says, hey, put all the class files for the source code into under ~classes. And when you run that, you'll see that it generates a class file in a directory that once again mirrors the package name. So ~classes edu pdx cs410j lang hello.class. Okay, so now you've compiled your source code, and now you want to execute your Java program. So you use the command line tool named Java, which invokes the Java virtual machine. Now you need to tell the Java virtual machine a couple of things before your program can run. First of all, you need to tell it the name of the class whose main method you want to invoke. And so what you do on the command line is you put the fully qualified name, which means the package followed by the name of the class. So edu pdx cs410j.lang.hello. Notice it's not the name of the class file. It's not hello.class. It's the name of the class. You also need to tell the JVM where to find class files, and you do this by setting something called the class path. This is the path, the file system path to where your class files live. And so you can use -class path or -cp here on the command line. And there's also environment variables that you can set, like $class path. So when I run a command like java-cp ~classes, which tells it where to find the class files, edu.pdx cs410j lang hello, that will then launch the Java virtual machine, and you'll tell it, hey, and you've told it, go off and load the hello class. Look for it in ~classes. It finds it. It executes the main method. And what does the main method do? Prints out hello world. For those of you who like to see things visually, you take the Java source code, you compile it with javac, turn it into a class file, you then execute the class file using the Java command on a JVM. Sound good? Okay. So that's sort of the life cycle of a Java compilation and running. I'll briefly run through I'll quickly run through some information about the pieces parts of the Java programming language. So there are you can have classes that are types. There are also 8 primitive types in the Java language. There's Boolean, which is true or false. There's char, which is a 16-bit Unicode character. There are 4 signed integral types: byte, which is 8-bit short; int long, which is 64-bit. And then there are 2 floating point types: float and double. And I assume that you guys know what integers and floating point numbers are. Okay, good. The syntax for literal values are basically the same as C. So you can have decimal, integral values. You can have hexadecimal, octal. Longs are the same. Long literals just have the letter L at the end. You have to delimit characters by using single quotes. And note that string literals are delimited by double quotes. And unlike in C and C++, where double quotes means an array of characters, in Java, double quotes actually means a string object. And we'll see what a string object is. So I think the important thing to note is that double quotes doesn't generate a character array. It generates something else, a string object. Comments in the language, very important thing. They basically have C and C++ style comments. Here's a little program that has examples of both. Probably the most interesting thing, though, are these so-called documentation comments. So if you have a comment that begins with /** and then ends with //, this is a special kind of comment in the Java programming language. Not as much in the language as it is a special kind of comment. And the information in these so-called documentation comments are meant to describe the class, or the method, or the field, or whatever that directly follows it. And there's this tool called JavaDoc that we'll see some examples of that will parse your source code, take out these comments, and generate really pretty documentation based on it. And this is really important for the Java programming platform, because one of the things that Java excels at is code reuse, meaning that I write some code and you use it. But I need to document my code so that you know how to use it and what it should do, and sort of what are the inputs, what are the outputs, what happens when things go wrong. And so when they were designing the language, they wanted to build in that means of having self-documenting code. So you don't have the man pages, which have to be maintained separately from your program or from your library.
So does that do it automatically, or because I'm not like I've been adding in those kind of code, and it's not altering my document. So
So then you run JavaDoc and it doesn't seem to be showing up? Is that what you're saying?
There's nothing.
That's weird. We should take a look at that a little bit later. Because when you run JavaDoc, I'll be able to find that stuff. Are you sure you're using the /**?
Yeah.
Do you start? Okay. Well, it's a mystery.
It'll automatically pull up like the parameters and stuff.
At the IDE or at the?
IDE.
Okay. Huh. Oh, well, we should take a look later. Blah 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 blah. Control flow. You've got the same control flow stuff that you do in C. Your ifs, your elses, your whiles, continue break, all that good stuff. For any of you that are like Fortran programmers looking for a goto, there's no goto. As a matter of fact, goto is a reserved keyword in the Java programming language, which is reserved to do nothing. So you can't have a variable called goto, you can't have a method called goto. Goto considered harmful, and then 20 years later they finally stopped using it. One thing that might be new to you guys, if you haven't, if you learned Java a long time ago, in Java 5 they introduced what's called the enhanced for loop, which allows you to iterate over arrays and collections using this for each syntax. So you say for each int I in my array, which is an array of ints, do something. Okay. Java has an exception facility, and an exception is an error that occurs while running your program. And there are different kinds of errors. Sometimes you have something like dividing by 0, or trying to read a non-existent file, or maybe indexing beyond the end of an array, or trying to dereference a null reference, things like that. If your program had to try to accommodate each one of these cases, it would be completely unreadable, right? Think about it. Anytime you did division, is the denominator 0? If so, take some other thing, right? When in reality, it would be very unlikely that it would be a 0 in the denominator. So to let your code focus on sort of the more happy path, or really what it ought to be doing, instead of trying to handle every situation that could possibly go wrong, Java has this facilities mechanism called exceptions that raise errors without cluttering up the code. So what happens is when one of these error conditions is detected, an exception is thrown, and there are some kinds of exceptions that require that the method explicitly say that, I might throw this exception. It's something called a checked exception, and we'll see more examples of that later in the course. So some code will throw one of these exceptions, and other code is responsible for handling the exception, for catching the exception and doing something with it. Maybe it's like printing an error message, or maybe it's just taking a different control flow, the control flow branch. So for instance, you attempt to read a file and the file can't be read because it doesn't exist. Well, simply prompt the user for a new file name. You don't need to crash, right? And of course, this is preferable to some of the systems that we had in other languages like segfaulting or blue screening or things like that. So it's better to get to have a nice way of handling this stuff. Real quickly, we'll come back to these in a later discussion. There are exceptions that are called checked exceptions, which are unexpected, but not terribly surprising. Like, oh, I tried to read a file and the file didn't exist. Okay, it happens, not a big deal. And these are these methods must be either handled when they're thrown, or the code that that may throw them. The method must declare that it throws or may throw one of these checked exceptions. The other kind of exception is called unchecked exceptions, and these ones are more rare and are usually more severe. Things like dividing by zero, or like you run out of memory. Like, how do you recover from this? Maybe you can recover from a divide by zero by asking them to enter a new number, but out of memory, you're probably out of luck. And because they're so severe, it's not the kind of thing either so severe or so common. Like, oh, you tried to dereference a null object. The program doesn't make you catch them. Instead, it'll just sort of like bubble up all the way to the command line and then explode all over your command line. And we'll see more here and more of that stuff later. Now, these exceptions are handled in your program using a syntax called try, catch, finally. So there are multiple code blocks here. So you say, hey, listen, I'm going to try to perform some operation. And so after this try keyword, you have a code block that may throw an exception or two. And if you want to handle the exception that may be thrown in that code block, you do so in what's called a catch block. So I want to try some operation, and if an exception occurs, I'm going to catch it here and handle it appropriately. So for instance, I might catch a file not found exception, simply print out an error message. Another exception that might occur while you're reading this file, maybe you get an end of file exception, which might be perfectly okay. In that case, you can ignore it. Now, it might be that there is some code that you want executed regardless of whether or not an exception was thrown. So it's like, okay, I got through that try block with no problems. Okay, clean up after yourself. Oh, in the middle of that try block, I encountered some exception. Okay, still clean up after yourself. And that cleanup code is put in a finally block down here. So like regardless of what happens, you want to close the file stream. Try catch finally is familiar to you guys? Okay, good. Here again, you get that remote control. You need me to go faster, you need me to slow down, you gotta let me know. Java 7, which was a version of Java that was, I think, finally rolled out about a year ago, maybe a little bit more than a year ago now, introduced a new language syntax for catching multiple types of exceptions in a try-catch block. Prior to this, code often had, let's say a read from file declared that it threw 5 different kinds of exceptions. Probably not a good practice, but there are some APIs that throw all sorts of different kinds of exceptions. And you'd have to have a catch block for each one of those types of exceptions that probably all did the same thing, print out an error and return. Well, now there is a language syntax. You can say try, catch, an IO exception or an SQL exception, and print out an error message. Anyway, nice little new language feature. Okay, packages. So as your application grows, it's possible that you might have naming conflicts. Meaning, for instance, you might have 2 libraries or 2 user classes in your system, right? As your system gets big. To distinguish between these 2 classes, Java has this package facility, this package mechanism. So every class is in a package, and the packages usually group together classes with similar functionality. So all the classes in the java.net package have to do with networking. Packages are kind of hierarchical in nature. All of the packages that come with the Java runtime, sort of the standard classes, have a package that begin with Java. So there's Java Lang and Java IO and Java.net and things like that. Here in this course, all the classes begin with edu.pdx.cs410j. And all the classes that you write for this course, I want you to put them in a package called edu.pdx.cs410j.yourUserID. So mine would be Whitlock and yours would be whatever your user ID is. The package declaration is the first thing at the top of a piece of source code. But it is optional, so you can have classes in not in any package, or rather in the default package. And maybe this is what you've seen before, but in this class we always use packages because, well, in your assignments you're all going to be writing classes with the same name. You're all going to be writing an appointment book class. But I need to figure out, whose appointment book class is whose. Sorry, which appointment book class is whose, and I do that by using packages. When one class wants to reference another class, you either need to fully qualify the name of that class or you need to import that class. Import is similar to a pound include in C or C++. The whole idea is that you're instructing the compiler, when compiler, when you see capital F file, what I really mean is the class java.io.file. So here's an example of fully qualifying a class like java.net.url. You can also import a file. You can import all the classes in a package by saying import java.io.star, and so that'll be all of the classes in the IO package. But note that star is not recursive, so you can't just say import java.star. You need to import each package. It's just the way the language works. Okay. Just to sort of, as a summary of the language part, some differences between Java and C++. Java doesn't have a goto. There is an exception mechanism in C++, but it's optional. In Java, it's mandatory, it's required, it's always there. I suppose we didn't really go into too much detail about pointers and things like that, but Java doesn't have pointers. There's no pass-by reference. There's objects or objects. We'll see more of that in a second. As far as operators go, there's no operator overloading. And there's no, so you can't do things like use left shift for I/O. This is not a very Java thing to do. There's no preprocessor, even though you have import, which is kind of like a pound include. And things like the negation operator, bang, can only be used with booleans. So you can't say something like not int value. What would you have to say instead? So here I have an int bad, and I want to say, well, if instead of saying if not bad, what would I have to do?
Not equal to 0.
Yes. Well, actually, well, there's no null for ints, so it's if not bad. Let's see here. I want it to be true if it's not equal to 0. Yes. So if bad, not equal to 0. Because here again, ifs require a boolean, and you can't use the bang on a primitive type. Before we move on, any questions about the language? Anything new here? Anything that you want me to drill down on further? No? Okay. Let's talk about some tools for working with the Java programming language. I suppose we've already seen Java and Java-C. There's also a tool called jar, and jar combines multiple files, usually class files, into a Java archive. And so what this allows you to do is put all the class files for your application or your library into one single file. That makes downloading easier. You can sign these jars digitally so that you know they came from you and haven't tampered with, stuff like that. And jar is a lot like the Unix tar tool. As a matter of fact, it's like almost exactly the same syntax. So you can create a jar file, and then you can get the table of contents T for the jar file, and it basically puts a whole bunch of classes into one archive. Jar files are interesting because you can put jar files on the command line, and the Java virtual machine knows how to read classes from a jar file. So instead of saying java-cp /classes, you can say java-cp classes.jar, and then give it the name of the class, and it'll go and load the class from that jar file. You'll be using jars a lot in this class because all the third-party code, so third-party to you, things like my example code, my course, my project classes, things like that, all live in jar files that are deployed out in Maven land, and you can watch the Maven lecture to get all sorts of good details on that. There's a couple of notes. Jar files can contain anything, so if you want to have sounds or icons or images or something like that as part of your application, you can do that. And a jar file contains a special entry called the manifest that just describes information about the jar. So what version it is, if there's digital signature information, et cetera, et cetera. And there is a Java API in the Java util jar package that can be used to manipulate jar files if you're so inclined. Okay, Java doc. As we mentioned, there are these special kind of comments called documentation comments that are that allow you to document various program elements, like, oh, here's a description of a class, or here's a description of a method. And there's this cool tool called JavaDoc that will generate pretty HTML, or actually there's a framework, and so it can generate anything based on the stuff in the documentation tags. Documentation comments. You can also use these special tags to provide additional information about your classes. So you can have an @author. Here's the person that wrote it, and you can describe parameters with @param. You can say, okay, this is the conditions under which an exception will be thrown. So here I have an example of some Java source code that has lots of JavaDoc comments in it. So here above the class declaration, I have a JavaDoc comment that describes the class. This class demonstrates JavaDoc comments, and the author is David Whitlock, and the version is 1.0. Here I have an invert method that takes a double D parameter, and here I have a JavaDoc comment that describes that method. So it returns the inverse of a double, and note that you can use these little pseudo HTML tag type things to say that I want this to be displayed in a fixed width font because it is code. You can have the parameter tag, which describes what the parameter is, the value that it returns, and also you can document the conditions under which an exception is thrown.
Can you put just arbitrary HTML for that?
You can, and it handles it pretty well. That being said, you don't want to get too complex, right? You don't want JavaScript or embedded Flash videos or whatever. I'm sure someone's tried it. Stuff like that. I think in hindsight, I wish they would have just had a simple markup language to use instead. I think it would have made things a lot more simple. But then again, it was the 90s, man. Everybody was learning HTML because we were going to go to Silicon Valley and become millionaires writing HTML, which was, anyway, which a lot of us thought. Anyway, and so I don't think we ever said it's the 90s, man. But anyway, because that sounds like it was the 60s. Anyway. JavaDoc. Yep. So when you run the JavaDoc tool from the command line, you need to tell it several things. You need to tell it where the source code lives, where the compiled class files live, and then where you want the HTML to be placed. So when you run a command line like this, it'll go off, do some analysis, and generate JavaDoc files. And so as an example, I'll go back to the, how much time do we have left? 6 minutes. I'll go back to the website. And here again in the top left corner, there's a link off to API docs. And here is the JavaDoc that I generate for all of my example code. It allows you to browse by package, by class, and then here in the main pane, you have all sorts of details. So let's see here. My JavaDoc example was in the CS410J Lang package, and so now I can go and find the JavaDoc class. And here is the JavaDoc that was generated from the source code. And let me go back and show it to you here. Okay, remember we have this class comment. This class demonstrates JavaDoc comments. That gets turned into this up here. And it interprets the @version tag and makes it nice and pretty and stuff like that. You can click on the method to get more detail about it. It's the invert method. And notice that it returns the inverse of a double. Notice double is in a fixed width font, just like we told it to in the source code. Depending on the options that you give to the JavaDoc utility, you can get things like links off to other places, so links off to other API documentation. So when I click on legal argument exception, it actually brings me off to Sun's documentation, Oracle's now, documentation for a legal argument exception. And I also have run this with an option that will let me easily see the source code for that class. anyway, really neat. It's really quite powerful. And I guess the for me, the big value of JavaDoc is that now you have very easy to generate API documentation for your Java classes. And so then it's much easier to communicate what it is that your code is supposed to do. And since the comments are right next to the code, it's hopefully easier to update the comments when you update the code. Any questions on that? Okay. I'm going to stop the recording and start over again because we're sort of halfway through.